Today in Capeggi's Corner, we're going to look at functions and their graphs. So the first thing we're going to look at is identifying the function. So remember, when we have this sort of mapping, my domain is my x values, my range is my y values. Now, we want to make sure also to decide whether it's a function or not. So when we're dealing with domain and range, the domain or the x values can only appear once. So we have our domain listed here and our range listed here. And if I go below, I've mapped them, and this is a good way to see whether it is a function or not. So in this case, my x values can't repeat, but in this case, they do. So when I do the vertical line test, it is not a function because it does not pass the vertical line test. Now, when I look at my mapping up here or even my values, I notice that here, the problem is when my x value is 4. It goes to both 5 and 6. So it's paired with both 5 and 6. So I can't have the x value more than once, which is why that is not a function. All right, let's look at our next example. Again, I have my domain and range. Now, in this case, I have two values going to 6 in my range or my y values, and that's okay. So when I list my domain, I have -2, 0, 3, 4. And then I also have -3. Now 6 actually has an x value, two different x values coming to it, but I only need to list it once. Okay, so now when I do the vertical line test here, I'm never going to hit more than one point or one x value. So this one is a function because it passes the vertical line. Again, if I look at my x values written as coordinates, I don't have the same number there twice. Okay, moving on. We're going to graph using a table. So what I did here, again, just to save some time, you're always welcome to pause the video and check it out. So here is my equation. Okay, and so I picked different values. I picked -2, -1, 0, 1, 2, and then I graphed it here. Notice that I have arrows on the end. Now, if I want to know if something is a solution, so the question is here, is 2, -3 a solution? I can plug it into that equation, right? -3 is y, and I get -3 is equal to 4 minus 7. Well, -3 is equal to 4 minus 7. So I know that that answer there is yes, it's a solution. Now, it's a solution if that appears on the line. So when I go to 2, -3, here's that point. That's another way I can decide whether it's a solution of the equation. Now, let's look at another one. I have 4, 2. Is that a solution? Remember, this is my x, this is my y. When I substitute that in, that does not work, right? 2 does not equal 8 minus 7. And you can see if I go 4, +2, that's not on my line. So again, that's not a solution of the equation. Okay, when we're dealing with function notation and trying to decide whether something is linear, remember linear is a line and things are a line if they're only ever to the first power. Okay, so we know that if we have x to the first power, it's linear. Anything else, x to the second power, x to a negative power, that's not going to work. Okay, so if I look at this and decide if this is linear, well, my highest power here is x to the second, so that's not linear. That's a no. My highest power has to be x to the first. Remember, in number 2, this is x to the first. We just don't write it, so that one's fine. Now, remember, this x is underneath. We can't have that. Remember, that's not x to the first. That's actually x to the -1, which we'll get to more in this course. So that's going to be a no. And number 4, although we have a fraction, that x is my numerator. So another way we could write this is that, again, x to the first power. So that's fine. That is linear. All right, moving on. Evaluate each function for the given graph. So I'm going to substitute f of -2. That's how you say that. F of x is equal to -3x plus 7. So I substitute that in anywhere I see an x. So I started there. F of -2 is equal to -3 times -2 plus 7. So that gives me +6 plus 7. So our final answer we will write as this. F of -2 is equal to 13. Okay, also something similar here. We have g of x. So same idea. We're going to substitute it in. Remember, negative 2 squared is negative 2 times negative 2. So that's going to give us positive 4. So I have 4 minus 4, which is 0 so far. But again, I have to remember that negative 10 up here. So I'm going to get 4 minus 4 is 0. So my final answer there is G of negative 2 is equal to negative 10. Okay, let's take a look at the word problem. In March of 1999, Bertrand and Brian, they attempted to become the first people to fly around the world in a balloon. So they have an average speed of 97.8 kilometers per hour. And the distance is what we can look for here. So that's our little equation. Distance equals rate times time, right? We have time in hours. The pair traveled a total of 478 hours. The rules governing their record state that the minimum distance covered should be at least 26,700 kilometers. Okay? And then we want to know the domain and range, and did they set the record? So our domain, right? Our domain is going to be our T. And we know that they did 478 hours. So we're going to go from 0 time up to 478 hours. Now, to find out what our range is, right, we're going to use that equation to see what we have for D. Okay, so we have between 0 and 46,748. Now, it said we must be at least 26,700. So did they set the record? Yes, they did. Okay, so we're going to graph the function now. Now, again, to save some time, I did set it up. So I picked 0, 0 to start with. And then I picked a value of 200 for time. I substituted it into the equation. I got 19,500. And then I went to the max of 478 and then 46,748 for D. So our X value is time, right? This is going to be, on our X value is time, is going to be in hours. And then our Y value is going to be that D in kilometers. Okay, so in this case, we don't have hours on the end. You can see I plotted the points. There's no hours on the end because we are starting at 0 and we're going right to 478 when we're talking about our x-axis, because that's the limit. That's how long they flew. So that's it, right? In that balloon, that was it. Okay, now it says approximate for letter C, approximate how long it took them to travel 20,000 kilometers. So again, here's my formula. I substitute in my 20,000 for D, and we're looking for time. So I'm going to divide both sides by 97.8. And to travel that distance, it took about 204.5 hours to get that far. Okay. All right, let's take a look at our last few here. Again, just some extra practice on deciding whether something is a function using the vertical line test. So in this one, it doesn't matter, number one, I draw the vertical line in lots of spots, but it does never more than one, so it passes the vertical line test. So yes, it's a function. Okay, looking at the next one, I draw my vertical line and never hit more than one spot. Now, right here, I do, if I were to draw my line through here, but this is a closed circle here, and that's an open circle. So this means I'm including this point, but when it's open, I'm not including that point. So that one's still okay. That's yes, it's a function. Okay, as opposed to number 3, when we get here, do you see that? Both of them are closed, so that's not going to work. That's not a function. Okay, thanks so much for stopping by today. You have a great day.